All right, this is grade 6, unit 2, lesson 2, and in this lesson, students are going to be moving from that concrete representation of ratios to the pictorial form of ratios, and we're going to continue practicing all the different ways to write ratios. So let's get started. All right, so we're going to start with just the classic warm-up that we always kind of begin with. And it says we're going to begin with a number talk, dividing by 4 and multiplying by a quarter. All right, so find the value of each expression mentally. All right, so the idea is we're going to start with some stuff that we know, right? 24 divided by 4 is 6. Why is that? Well, that's because there's 6 4s in 24. You could take that 24 and you can cut it into how many 4s go into 24. And you could say, well, there's 4, 4, 4, 4, 4, 4. That equals 24, so there's your answer is 6, right? A quarter times 24, so that's a quarter of 24. That's the same problem as this, right? So that's also 6. That's another way to think of that is to take your 24 and take a quarter of it, and in which case each quarter is equal to 6. So you got a couple of different ways to think about that. Both answers are 6. 24 times a quarter. Well, a couple of ways you could think of it. You could think of it as the same as the previous problem, a quarter times 24. But another way you could think of it is 24 copies of a fourth. So you're going to have a fourth, 24 times. And eventually you're going to get 24 fourths, which is equal to 6, right? And of course, we're supposed to be doing all of this mentally, but I'm just writing stuff out. And then 5 divided by 4 is going to be 1 1/4. And how do we know that? So you could take 5 and you could cut it up into 4 pieces. And so, each piece is going to have 1, but that only adds up to 4. So that remaining whole number has to be cut up into, let's zoom in a little bit. That remaining piece has to be cut into fourths to pass those out. And that's how each piece gets 1 1/4. That looks like a 1/6. It's a 4. 1 1/4. All right, so there you go. So there's a nice little warm-up. Okay, so we're going to move on to the lesson. Here's a collection of snap cubes. All right, so now parents and teachers, you could give actual cubes to your students. In fact, it's probably preferable that you did that. I'm not going to do that because I'm going to kind of go cheap and just make a quick video. But man, it would be really beneficial if you would actually hand out cubes to your students. Anyway, over here on the directions, it says choose 2 of the colors in the image and draw a diagram showing the number of snap cubes for these 2 colors. So the idea, parents and teachers, is we're taking the concrete and we're guiding students towards the idea of drawing it. So we're taking the concrete and we're moving to the picture form, and eventually we're going to move to the abstract form. So CPA is a classic instructional approach, and this curriculum is doing that, starting with the concrete, moving to the pictures, and then wrapping it up with the abstract. So students are going to choose any of the 2 colors. They're going to draw an image of it. And then down here, they're going to trade their paper with their partner and write a sentence to describe a ratio shown in their diagram. So the idea would be, so if I was a student, I would say, okay, I'm going to take the yellow one and the pink one. All right, now, because I'm having a hard time seeing exactly how many is the yellow, I need to zoom in, and I can see that the yellow is 1, 2, 3, 4, 5, and that the pink is 1, 2, 3. All right, so then I'm going to zoom out here, and then it says, okay, so I'm supposed to draw those, and I'm going to draw 5 for the yellow, 1, 2, 3, 4, 5, and 3 for the pink. And I'm trying to make them reasonably accurate. And because I'm just using a pencil, right, I'm going to zoom in and I'm going to write down a Y, a Y, a Y, a Y, a Y, a pink, a P, a P, a P. Gosh, that's gross. Okay, so anyway, to demonstrate that those are supposed to be yellow cubes and pink cubes, and now students are going to trade papers, and they're going to write a sentence to describe the ratio. So what might a student say for my drawing? Well, a student might say that the ratio of yellow to pink is 5:3. All right, so that's something. That's an example of what students might write. Moving down, and then of course you're supposed to return your paper to your partner, and then read the sentence to see if you agree or disagree. And parents and teachers, the purpose of this, it's a nice intro, but it's also doing best practice, which is getting students to practice their academic language. So this is absolutely best practice. This is really amazing stuff. Okay, so 2-3, blue paint and art paste. So Elena mixed 2 cups of white paint with 6 tablespoons of blue paint. So here you go. These 2 green squares represent white paint, and all of these little things represent your blue paint. Here's a diagram that represents that situation. Now, parents and teachers, we've got just a ton of stuff that we want our students to start discussing. Again, we're practicing our academic language, and that's the point of all of this. So students are going to work in teams and partners probably. That's probably best practice. And make sure they both agree. So the ratio of cups of white to tablespoons of blue is 2-6. And we're going to say, yes, that is correct, because we can see that there are 2 things representing the white paint and 6 things representing the blue paint. So do we agree? Yes, we agree. So we're going to say, yes, we agree. Okay. For every cup of white paint, there are 2 tablespoons of blue paint. So as we look up here, we're going to look at groupings, and we actually see that for every cup of white paint, we actually have 3 tablespoons. Is it tablespoons? Yeah, tablespoons of blue paint. So we don't agree with that. No way, we don't agree with that. And then it says there is 1 cup of white paint for every 3 tablespoons of blue paint. And that's exactly what we discovered up there. So we're going to say yes to that. That's a yes. And then D, there are 3 tablespoons of blue paint for every cup of white paint. Well, that's the same as this statement here. It's just the opposite. So we are going to agree, because parents and teachers, we want students to be flexible in thinking that the ratio here is 1-3, but we could also describe this ratio as 3-1, all right, or 6-2 and 2-6. That they're not equivalent ratios, but we can choose to describe that situation using either ratio. So that's a key distinction. They're not equivalent. 2-6 and 6-2 are not equivalent, but they are both describing the same relationship between those objects. And then the idea is you just keep going. For each tablespoon of blue, there's 3 cups of white, and et cetera, et cetera, et cetera. Do we agree? Do we disagree? And that's just beautiful stuff. Now the ratio of tablespoons of blue, oh no, that's just more of the same. That G, that's just more of the same. Just do we agree? Do we disagree? Just keep going. All right. So moving on, Jada mixed 8 cups. Whoa, my goodness, what happened here? Okay, so Jada, there we are, mixed 8 cups of flour with 2 pints of water to make paste for an art project. All right, draw a diagram that represents that situation. So 8 cups of flour, 2 pints of water. So let's do it. So we're going to say, I'll do my flour in green. So we've got 1, 2, 3, 4, 5, 6, 7, 8 cups of flour. And of course, I'll do my 2 pints of water in blue. So there is my flour. I'll put F for flour. I'll put W for water. And there we go. I've just drawn a diagram that represents the situation. Notice, parents and teachers, I'm not being all that fancy with my artwork. I'm just squares is good enough. Now the idea is write at least 2 sentences describing the ratio of flour and water. And so we could say anything, couldn't we? We could say the ratio of flour to water is, and we could say 8 to 2. We could have said the ratio is 4 to 1, couldn't we have? We could have said the ratio is 4 to 1 because we can see that there's 4 flours for every 1 water. So there's a lot of statements we could have made right here. And parents and teachers, your job is to let students explore and try and describe as many relationships. And by the way, I just noticed I wrote the word ration. Should have been ratio. All right, moving on. Now this is kind of neat. This is really neat. It says we've got a card sort. And so the teacher, parents and teachers, you're going to, I'm going to zoom out here just a little bit. You're going to give your students a bunch of sentence cards, all right? And you can't read them quite yet. Don't worry about it. And then you're also going to give them some diagram cards. And actually, it's on the Black Line Master. You could just give it to them, and the students can cut it out themselves because the answers are not provided. That's kind of cool. And so the idea is now students are going to try and take a diagram and match it to the right sentence. And so in this case, we've got diagram F. We see 3 objects, and then here in the sentence it says cups of tomato sauce, tablespoons of oil, and teaspoons of oregano are in the ratio of 1 to 5 to 2. Ooh, look at that. I happen to find a match. Here's 1 to 5 to 2, and there's our items over here. And so therefore, these 2 things are a match. And we're just going to continue taking each diagram, trying to find a match for your stuff. Now, I technically don't know if this is a match because I don't know. This diagram doesn't say that the squares represent tomato sauce or the squares represent the oil or the squares represent the oregano. So I'm thinking this might be a match, but I don't know until I just continue matching. The idea is to match your diagrams with your sentences, paying attention to the ingredients in that what do I want to say? In the story, right? So I'm going to get these guys out of the way because I need to. I'm going to get these out of the way. Go. Get out of the way. Get out of the way. Get out of the way. Because I am going to keep going. All right. So here we go. And there we are. Woohoo! So then we're going to have a whole conversation based on that wonderful card sort. Students are going to answer their questions. And really, parents and teachers, the purpose of this whole thing is to get students to practice academic discourse. We got some summary here. When we have concrete objects, we can take those concrete objects and we can draw them as just simple representations, and then we can start writing statements about that because we are moving from the concrete to the pictures to the abstract. All right, let's do a little bit of practice. All right, here's a diagram that describes the cups of green and white paint in a mixture. Select all the statements that accurately describe this diagram. All right, so I see the ratio of cups of white to green. So white to green is 2 to 4. White to green, 2 to 4. That's a true statement. Woohoo! So that's a true statement. And then it says for every cup of green, there are 2 cups of white. That's not true. That is not true. In fact, it's going to be the exact opposite. So we're going to say false. All right. And then the ratio of green to white is 4 to 2. That is a true statement. That is a true statement. And then for every cup of white, there are 2 cups of green. For every cup of white, there are 2 cups of green. White, 2 green. So, yep, that happens to be a true statement. And then lastly, the ratio of green to white is 2 to 4. The ratio of green to white is, no, it's the reverse. It's 4 to 2 is green to white, not 2 to 4. So that's false. All right, and so there we go. Now we know which ones are true and which ones are false. To make a snack mix, combine 2 cups of raisins to 4 cups of pretzels and 6 cups of almonds. So we've got 3 objects being compared at this point. Create a diagram to represent the quantities of each ingredient in this recipe. All right, so I'm going to do 2 to be my raisins. The black will be my raisins. We'll do blue to be my pretzels. And then we'll do green to represent my almonds. 1, 2, 3, 4, 5, 6. And there is my diagram. Done. Use your diagram to complete each sentence. So the ratio of, and then you, parents and teachers, get to tell the students that they get to choose their own problem. So if we want to do, let's say raisins to pretzels to almonds, then the ratio is 2 to 4 to 6. And then we have some unit ratio questions. There are blank cups of pretzels for every cups of raisins. So for this cup of raisins, there are 3 cups of, oh, no, it's the pretzels. It's the pretzels. Oh, yikes. How do we undo? I don't know how we undo. Is there an undo? Oh, yep, there's the undo. 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 There it is. Woohoo! All right, so the blue are the pretzels. So for every raisin, there are 2 pretzels. And then a similar question, there are blank cups of almonds for every cup of raisins. Ooh. So again, we're going to do, for this cup of raisins, there are 3 cups of almonds. And this cup of raisins, there are 3 cups of almonds. So we see that ratio, that unit ratio is where we're kind of guiding students towards. Yikes, I don't want to undo grouping. How do I fix that? Oh, golly. How am I going to fix that? Let's see. I'm going to do that, and then I'm going to group. And then I'm going to do that, and I'm going to do group. And we're going to see if that works. Ha ha! It worked. Yay! Okay, good. All right. Yikes! All right. And then it says, okay, a square is 3 inches by 3 inches. What is its area? Oh, a little bit of review, right? So a square is 3 by 3. 3 by 3. So what is its area? Its area is 9 square inches. Remember, you put that little 2 there. A square has a side length of 5 feet. What is its area? So that square is going to be 5 feet. So the area is going to be 25. So I'm going to do a little bit of erasing here. Get this out of the way. So the area is going to be 25 feet squared. And then the area of a square is 36. So this time they're saying that the square has the area of 36 centimeters squared, which means each side length must be 6 centimeters. So there you go, a nice little bit of review. Number 4, find the area of this quadrilateral. How do you know? So, golly, this is a bunch of review. Remember, area is you're counting the squares inside that figure. So, all we have to do is count all these little squares, but I'm probably going to divide it up into some shapes so that it's easier for me to count the squares inside each of those shapes and figure it out, although I do see some symmetry. So if I found one triangle, I automatically know the other triangle. So I'm going to take advantage of that. Beautiful. Man, this is a good question. And then lastly, complete each equation with a number that makes it true. So this is beautiful. This is a great problem. So this is a quarter of 8. So that answer is 1. And then if we know that a quarter of 8 is 1, not a quarter, an eighth of an 8 is 1, then 3/8 of an 8 must be 3 because it's 3 times as large. And then we can go over here, 1/8 of 7. 1/8 of 7 is going to be 7/8 because you got to divide, right? 7 divided by 8 is 7/8, right? And then so 3/8 is going to be 3 times as big, so that's going to be 21/8. And that wraps up Grade 6, Unit 2, Lesson 2.